Hand tools for electrical maintenance identify basic tools and their safety aspects. Tips for hand tool safety.
Safety precautions to be taken prior commencing work or repair of electrical equipment with electricity. Avoid water at all times when working with electricity. Never touch or try repairing any electrical equipment or circuits with wet hands. It increases the conductivity of electric current. Never use equipment with frayed cords, damaged insulation, or broken plugs. If you are working on any receptacle at your home, then always turn off the mains. It is also a good idea to put up a sign on the service panel so that nobody turns the main switch on by accident. Always use insulated tools while working. Electrical hazards include exposed energized parts and unguarded electrical equipment which may become energized unexpectedly. Such equipment always carries warning signs like shock risk. Always be observant of such signs and follow the safety rules established by the electrical code followed by the country you're in. Always use appropriate insulated rubber gloves and goggles while working on any branch circuit or any other electrical circuit. Never try repairing energized equipment. Always check that it is energized first by using a tester. When an electric tester touches a live or hot wire, the bulb inside the tester lights up showing that an electrical current is flowing through the respective wire. Check all the wires, the outer metallic covering of the service panel and any other hanging wires with an electrical tester before proceeding with your work. Never use an aluminum or steel ladder if you are working on any receptacle at height in your home. An electrical surge will ground you and the whole electric current will pass through your body. Use a bamboo, wooden or a fiberglass ladder instead. Know the wire code of your country. Always check all your GFCIs once a month. A GFCI, ground fault circuit interrupter, is a RCD, residual current device. They have become very common in modern homes, especially damp areas like the bathroom and kitchen, as they help avoid electrical shock hazards. It is designed to disconnect quickly enough to avoid any injury caused by overcurrent or short circuit faults. Always use a circuit breaker or fuse with the appropriate current rating. Circuit breakers and fuses are protection devices that automatically disconnect the live wire when a condition of short circuit or overcurrent occurs. The selection of the appropriate fuse or circuit breaker is essential. Normally, for protection against short circuits, a fuse rated of 150% of the normal circuit current is selected. In the case of a circuit with 10 amperes of current, a 15 ampere fuse will protect against direct short circuits, whereas a 9.5 amperes fuse will blow out. Working outside with underground cabling can be dangerous. The damp soil around the cable is a good conductor of electricity, and ground faults are quite common in the case of underground cabling. Using a spade to dig at the cable can damage the wiring easily, so it is better to dig at the cable by hand while wearing insulated gloves. Always put a cap on the hot, live wire while working on an electric board or service panel, as you could end up short-circuiting the bare ends of the live wire with the neutral. The cap insulates the copper ends of the cable, thus preventing any kind of shock even if touched mistakenly. Take care while removing a capacitor from a circuit. A capacitor stores energy, and if it's not properly discharged when removed, it can easily cause an electric shock. An easy way to discharge low voltage capacitor is that after removal from the circuit is to put the tip of 2 insulated screwdrivers on the capacitor terminals. This will discharge it. For high voltage ones, a 12 volts light bulb can be used. Connecting the bulb with the capacitor will light up the bulb, using up the last of the stored energy. Always take care while soldering your circuit boards. Wear goggles and keep yourself away from the fumes. Keep the solder iron in its stand when not in use. It can get extremely hot and can easily cause burns. Isolation procedures for safe working on electrical systems and equipment. This instruction chart illustrates the safe isolation procedure to be applied when working on electrical systems and equipment. Isolation means the cutting off of the electrical supply to an electrical installation for safety reasons. This is carried out by operating devices that have been provided within the electrical installation for isolation to make the electrical system, or part of it, dead. Once the electrical supply has been isolated, the means of isolation must then be secured so that the system, equipment cannot be inadvertently made live. It is important that all sources of electrical supply are isolated and the system, equipment proved to be dead before work is carried out. The Electricity at Work regulations requires the isolation of electrical equipment and systems to prevent danger. The regulations also state that no person shall take part in any work activity unless they possess the necessary technical knowledge and experience in order to prevent danger, or is under suitable supervision. One fundamental safety-related work practice is that exposed, live electrical parts must be de-energized before work on or near them is permitted. The only exception to this rule is when a qualified person is available and it is absolutely necessary due to equipment design or operational limitations. If this happens, other work practices must be followed to protect that person. The bottom line is that all of us, including unqualified and qualified persons, must protect ourselves from all potential contact with live electrical parts. Protection may be provided via shielding, insulated tools, or protective electrical gloves and clothing. To properly isolate electrical energy and prevent exposure to electrical hazards, the system or its parts must be locked or tagged out in accordance with your company lockout (TAGU) policy. Lockout is defined as the placement of a lockout or TAGU device on an energy isolating device, such as an electrical disconnect switch, in accordance with a written procedure. This is performed to ensure that the isolating device will be controlled from inadvertent or accidental operation until all employees are safe and the lockout TAGU device is removed. Regarding work on an electrical system, a lock with a tag must be placed on all disconnecting devices. The lock must be securely attached and locked. The tag must contain a statement prohibiting energization or operation of the equipment and removal of the tag. In addition, a qualified person must test the equipment to verify that the circuit elements and parts that are isolated are in fact de-energized. Electrical equipment should never just be presumed to be dead. Verification is always necessary. If the electrical system is over 600 volts, the test equipment used by the qualified person must be checked immediately before and after to assure proper operation. A very important safety procedure is the re-energization of electrical disconnect switches. If an electrical malfunction should occur, it is critical that you and other employees are clear of the electrical equipment. Never stand in front of a disconnect switch when you are energizing the circuit. Proper closing or activation of switches means that you always stand to the unhinged side of the cabinet. Close the switch with your near hand or arm and turn your head away from the cabinet. This is done to reduce the risk of injury in case of a malfunction of the switch starter, which could cause the release of an arc of energy. Although this is a rare occurrence, it can and does happen. If this were to occur, you could be struck by the cabinet door and seriously burned by the intense electrical arc. Electrical problems are usually minor, but it is the situations that turn them into electrical emergencies. In such cases, it is important to react immediately and smartly since electrical emergency can pose serious risks to you and your family.